Okay, so in the reaction mechanism for the bromination of methane, um, it's an example of what is called a substitution reaction, not an addition reaction. That's for a different type of substance. This is a substitution reaction, and it happens in fully saturated molecules. So for instance, in the methane molecule here we have all single bonds, so this is completely saturated. There are no double bonds that can be broken in order to have addition take place. So the only way that you can change this molecule then is by literally taking one of the H's from the outside and adding on bromine in this case on the outside, and that is just a substitution. The H gets substituted for a bromine, and that's the substitution part of the reaction discussed, and it has to do with the fact that it is completely saturated. Okay, so then we have to start discussing then, well, where is the energy coming from that takes a stable bromine molecule and causes the bonds to break, okay? And this is where the light plays its part. Okay, so the ultraviolet light has just the right frequency, which then infers the correct amount of energy to cause the bromine molecule to split. And in the half reaction you see that the electron pair that we're sharing here in this covalent bond, an electron goes to one bromine atom, and the other bromine in the pair in the covalent bond goes to the second bromine. Okay, so look at this is the overall reaction that we have then. Okay, we have our reactants at the beginning and we have our products then at the end. Okay, but there are three steps in this overall process, and step one is called initiation, and this is the thing I just discussed a moment ago, where we have our UV light present, and when the UV light is present, then we have the breaking down of a bromine, molecular bromine. Okay, this is step one. It's called initiation, and we end up with two of these bromine radicals, is what they're called. Then when you have a single electron, we have one, we've got a bond pair, a lone pair, a lone pair, and a lone pair of electrons, but this one then is an electron on its own. It's not a lone pair because it's just a single electron by itself. Okay, so given that it's a bromine radical, okay, it also means that it's highly electronegative, okay, electronegative, so therefore it has a strong ability to draw electrons. This also means that it also satisfies another term which is called an electrophile. Okay, so in other words, it wants to gain an electron, so therefore it's called an electrophile. Okay, so then we have our electrophile, the bromine, and then we have our CH4 methane molecule here, and we're highlighting one of the bonds. We have the CH3, well, it's CH4, but we're looking at one of the hydrogen bonds, these covalent bonds. We have an electron pair, a covalent sharing of these electrons, one from the hydrogen and one from the carbon, because the carbon is in group 4 and it has 4 valence electrons, one of which is being shared with this particular hydrogen here. But in any case, this part of the methane molecule then is in a position to give an electron. So we have our electrophile and then we have our nucleophile, which is willing to give one of the electrons away. And you see that on the right, on the product side of this reaction, which is part of the propagation step in this overall reaction, we end up with our HBr, which then leaves us with CH3 with an unpaired electron, so it means that we have an extra electron here that actually is not bonded to anything. So we have a CH3 radical now at this stage. So in propagation, it means that we have a progression of this effect dominoing its way through the mixture. So the bromine radical has now, as an electrophile, taken an electron from a methane molecule, which now has created, if you like, a methyl radical, and then the methyl radical is in a position then to go and break down molecular bromine, and we end up then with a bromine radical, and this is what's called propagation, when the initial substance, or the initial radical, has, if you like, chain reacted its way through. This one was the start of the chain reaction, but the chain reaction then continues, and we have several different types of radicals, and these radicals then affecting different molecules. And this is the propagation step, stage 2, after initiation. Okay, and in the propagation step as well, look, take note as well that steps 1 and 2 are then repeated over and over in a, well, I guess not a completely infinite cycle, but somewhat of an infinite cycle. Okay, but it does then finally reach a termination stage, and this is the next step that we just want to discuss. Okay, then in this termination step, then step 3, we're talking about these radicals then bonding with one another. So we have our bromine radicals bonding together and achieving a successful octet, 8 electrons on the outer shell. We get molecular bromine. We get bromine bonding with this radical, the CH3 methyl radical, and we get molecular bromomethane, and we also have the CH3 radicals that we talked about, the methyl radicals, 2 of those bonding together, and when that happens we end up getting C2H6, which is ethane, and this then is taken as termination, where basically the reaction grinds to a halt, and we have a lot of settling down where all of the bonds take place, and we get stable molecular products.